This next angle is really large, so we're going to have to figure out how many times around the circle it goes and then figure out when it terminates. So if we take that angle and divide it by 360, that'll tell us how many times around it goes. So when you divide by 360, your calculator is going to say 13.6 something. So that whole number tells you how many full times around the circle it goes. So if we have our vertex at the origin and our initial side on the positive x, we'll go around 13 times. You don't need to count those, just kind of know it's going around multiple times. You can put times 13 if you want. But then we need to figure out where does it stop, because it doesn't stop at the x-axis, it keeps going. So if it goes 13 times, we want to figure out, well, how many degrees is that? So take 13 times 360, and that's 4,680 degrees if we were to end back on the positive x. But we need 4,897, so we need to figure out what's the difference. How many more degrees do we need to go? So take what you need, subtract what we already have, and that's how much we still have left, which is 217 degrees. So that is going to tell us where to terminate. We're going to pass 90, pass 180, and we're going to end up in quadrant 3. So this would be 4,897 degrees. Now we want to find our reference angle. So we want to find this distance here. So let's think about what is coterminal with 4,897. 4,897 is the same as if you were to start here and end there, instead of going the 13 times around, and that angle is 217. 217. So if I want to find the reference, then I want to take 217 and subtract 180, which is the closest x-axis to that. You could take 4,897 minus 180, but then it wouldn't be acute, and we need it to be positive, acute, and measured from the x. So if I subtract those, I get 37 degrees. So the reference angle here is 37 degrees. There are smaller units of measurement than degrees. So degrees has a little circle as its symbol in the top corner. Minutes is a unit smaller than degrees, and that is an apostrophe, and then seconds is like a quotation. So we've got a problem here where we've got 180 degrees and 137 degrees in 24 minutes. We want to find the reference angle. So they're already starting the process for us. So 180 minus 137 degrees, 24 minutes. Now, just like in elementary school, when you subtract vertically, you have to have a number to subtract from. You can't have 0 minus 24. So what we're going to have to do is we're going to have to borrow a degree so that we can have some minutes to subtract from. Now, when you borrow a degree, that only gives you 60 minutes. So there are 60 minutes in a degree, 60 seconds in a minute. So we borrowed 1 degree, so it went down to 179. And instead of a 10, like usual, that gives us 60. And now we can subtract down, and we end up getting 36 and 42. And so that is an example for finding a reference angle. Example 4, we've got this. And first we want to sketch it. So that's really large. We're going to divide by 360 to see how many times around the circle it goes. On your calculator, you don't need to put the 10, because we're just trying to see how many times around it goes, and 10 isn't a full, it's not even a full degree. Okay, so you get 25.019. 25 is your number of revolutions. How many times around the circle it goes. So if we're looking at this, it goes around 25 times. Then we want to figure out how much is 25 times around? So we're going to do 25 times 360, and we get 9,000. But we want 9,007 degrees and 10 minutes. And we've already gone 9,000 in 0 minutes. So we want to figure out how much is left. So that means we're left with 7 degrees and 10 minutes. I don't need to borrow because 10 minus 0 is still 10. So that's how many more we need to go. So if I go another 7 degrees, that's going to end in quadrant 1. And like we said in the table on the last page, quadrant 1 is its own reference angle. So the reference angle is itself. We don't need to subtract from 180 to find it. Example 5, we've got 352 degrees and 16 minutes. This is smaller than 360, so we don't need to do the whole dividing thing. We can go ahead and sketch it right away. Supposed to be on positive x. Rotate around into quadrant 4. It's not quite 360 yet. Now I want to find the reference angle, which would be this space here. The closest x-axis is 360 degrees. So we're going to take 360, subtract 352 degrees, 16 minutes. Here we've got that situation where we can't subtract 16 from nothing, so we're going to borrow 1 degree. That gives us 60 minutes. Then we can subtract each column, and we end up getting 44 minutes and 7 degrees. And that would be your reference angle.